So when it comes to dealing with this periodic table, what are some things you can tell me about that? Especially periods and columns. Why is that so important? Okay, one of them will tell you the energy levels if it is an S block or a P block element. Remember D's and F's that we can't utilize that, but S block elements and P block elements we can. All right, so let's see here. Must have it on the wrong function here. But yes, we will continue with that. Not right now, but we'll get to it eventually. And notice what it says here. Okay? It could be such thing, maybe I'm too far ahead with that. Yeah. Need to back up, you say? Okay. How's that? One more, you say? Okay, so this must be where we left off with. Okay, so then this is where we would begin then, correct?
No, we did this.
Oh, we did this. Okay. Okay. We have that too. Okay. All right. So we've illustrated this concept here before. Okay. So someone give me an example of a group 1 element. That's right, because it's in column 1. Just like lithium, sodium, potassium, and lithium. I think I said that twice. But yes, those are all elements in group 1, so they're going to have very specific properties. Most importantly, one valence electron, because what determines an element's reactivity? The neutrons, the electrons, or the protons? You're right. Why is that? Well, true, but it does, because it's where do you find electrons besides the cloud structure? They're rotating around the nucleus in various what? Periods or true energy levels. That's right. They're rotating around the nucleus in various energy levels, and that determines its reactivity. And it gets to be a little complicated to explain why perhaps certain D block elements have what we call various charges, like iron and manganese and cobalt, nickel. Those are all examples that have more than one charge. And we're not going to go into that at this level. That's more so of a junior level general chemistry application. It's just one of these. This is how it works. This is why. So then we just accept that and move forward. So does everyone have this information that wants it? So again, valence electrons, we illustrated that even with that activity that we did with your M&Ms. We tried, but what had slipped my mind, I never gave it enough thought, was we just didn't have enough various colors of M&Ms to do those various activities. But that's just the way it is. and we've talked about this in class, okay? It said skip the middle groups. So who are we referring to when we say 3 through 12 are the middle groups? The D block, okay? Yes, because again, those majority of them have more than one charge. And if you're sitting over here, if you look close, they're called transition elements, okay? So in basketball terms, what does it mean to be in transition? Yeah, defense to offense is probably but it's still offense to defense as well, because what happens is you get the rebound on defense and you throw it out to your guard and you're in transition to hopefully get down the court, get a easy basket or a layup. So that's why these are called transition metals, because the majority of them will have more than one charge. Not all of them. Silver would be an exception. Zinc is also an exception. But it's one of those things, just look at where they're located on the periodic table. Way out here in group 10 on that periodic table. There's zinc, of course. There's silver. And there's probably some more various ones in here. But the majority of them do have more than one charge. And then also when we looked in the chapter book, I said pay attention to, it was a abbreviated form of the periodic table that only had 8 columns in it. Okay, so hopefully when we let's say reinforce that number 8 is so important, because that deals with how these atoms bond with one another. So during this video, what did they say? These electrons is kind of like a shell game, okay? And that is specifically what you would call these, as different energy levels or shells, that certain electrons will go into the S block, that shell, or the P block, or that shell. And the goal of sodium and chlorine is to do what? To get how many in its outer energy level? And how many would full be? You're right. 8. So either losing electrons to get to 8 or gaining them to get to 8. That's why we go back to you moviegoers. You nice gentlemen, you got your $5 bills, they're electrons. Ladies, I don't know. You're not grabbing those electrons. Well, we looked at it that way, but maybe that's not the way you want it explained. And that is kind of mean, so my apologies. Not all guys are the same. Not all gals are going to be the same. So, but we said this before. What would you prefer, ladies? You pay your own way, or the gentleman should take care of it? Okay, I agree, but that's not how all people think. If we all thought the same way, just think how boring that would be. So, okay. See, I want to make sure we get to a certain spot. We're slowly wrapping this up. Okay. So for the most part, this would make sense, except for when you get to 3p6. Why would this get to be confusing after 3p6? P6. Right. And again, some of these concepts are, like I said, more so of a general chemistry application. So it's not that you wouldn't believe that this is what we're talking about, but maybe it would make sense if you just read, would you like me, I'm holding this upside down, would you like me to read this paragraph, or one of you want to volunteer? It's just a couple sentences. But how do you know I'm not making this up? It'd be pretty hard to do that, wouldn't it? You see, that's one of the things that comes to, let's say, homework. I know a lot of you don't like doing it, but in my opinion, I think a lot of you would agree, it's just a lot easier just doing that work than just skipping out and doing other things. All of a sudden, it all starts to pile up. Would that make sense? For some of you who may think of, college is expensive. Why not let the U.S. Air Force pay for it? Why not let the U.S. Army pay for it? And whether some of you think that way, maybe yes, maybe no, there are those opportunities. But going through that process, unfortunately, some people get far away from home for the first time, so they become homesick. And the quickest way to get through basic training, just do the work and get through it. But unfortunately, like I said, not all people think the same way. So what's so funny, in my opinion, us individuals here in the Midwest, what's our work ethic like, do you think? Pretty high or pretty low? It's pretty high. Okay. I honestly think, and this was it was kind of explained to us when we were overseas, a lot of let's say other units that had high-ranking officers said, "Where are you from?" "South Dakota." I said, "Man, you guys know how to work." And I think that's a tribute to what our work ethic is, because a lot of you, growing up on farms or just being in the Midwest, you pretty much have a good work ethic. So again, the quickest way to get through that is just do the work and get it over with. Singing songs probably helps too, right? That's exactly my point. Okay? So,
I heard you a tiny bit.
still little, huh?
It's at 68. All the way off.
Okay. But believe it or not, there are people who probably do take this seriously and probably want to do well. So when we have these little interruptions like this, it really hampers people's understanding of this. But what this might look like, this is an upside down version. What does that kind of remind you of if we take this and flip that over? What does it kind of look like? Okay? Even better would possibly be what? If it's doing one of these. Your slide rule. This is a depiction of your slide rule. Even though it's upside down, but you can also read it this way. But what it says, okay? Note that in the figure, for example, that the 4s sublevel is lower in energy than the 3d sublevel. Therefore, the 4s orbital is filled before any of those electrons can enter the 3d orbitals. So that's why we have that slide rule. It makes that correction for you, which you could say it kind of contradicts this. These electrons will enter or fill the inner energy levels first. That is true. That's why you might think, well, 3 has to be lower than 4. Well, I would agree. But still, because of the shape of these orbitals, that 4s sublevel fills before any will enter that 3D. And that's what that slide rule is for. That's why it's a good tool to utilize. Too much coffee or not enough? Must not be enough. Okay, so I'm thinking maybe just one more. Yeah, that would probably be good. We'll end with this for today. For writing things down, I just want to maybe make a couple mental notes up on the board. have a couple announcements and then we'll get to that video. Especially that second point. Okay? So notice we're spending a lot of time on electrons. And there's a reason for that. Because again, that determines that element's reactivity. Okay, does everyone have this information that wants it? Okay. And a couple things, well, what I want to go over on this assignment board, whether it's at the website, I think we've had this conversation before. How many of you like utilizing this? That's one of the first things. I wouldn't say the first thing. Maybe on Monday morning you come in and take a peek. Okay, that's what we're doing this week. Okay? But especially when this time of the year when we get further into the winter, okay, as we all know, what can happen. How many days of school do you think we missed last year?
Like 12.
Okay? So with that, what we would see is I want to use this as an example. Let's say, for instance, okay, we could review some of these problems. I got those papers corrected. I'll hand them back to you. Okay, so we review. But it says on the schedule that there's a problem quiz, which we'll have. But let's say there's no school tomorrow. We're just using that as an example. So what does that tell you about the evaluation? It doesn't get pushed back another day. What that means, what's your interpretation of that? So let's see if we're all on the same page. No. But what I'm saying is if we don't have school tomorrow, which we're going to, there's some impending weather coming in, but that's not until Friday. But should we not have school tomorrow, my point is the next time that we would see you, that's when that problem quiz is, even if we don't have school. But yeah, we are. Okay, let's say, okay, I did say that, but since I glanced over here, okay, so let's say tomorrow we reviewed, and then Friday we get out early, what have you, and we didn't have class. That means the next time that we see you, you're going to have that evaluation Tuesday. And I don't like having due dates on the first day of the week or evaluations on the first day of the week. But if Mother Nature interferes with that, that's how it is. Like it, don't like it. We only have so much time throughout this semester to keep moving forward. And I think you would agree that that's probably the best way to look at that. Okay? But since we have said that, since I have said that, I'll go ahead and take care of that. You'll have an assignment tomorrow then. So what that means is we'll go ahead and erase this and then put that over here, problem quiz on Friday. So let's say, for instance, that weather does come in. Let's see here, assign worksheet 2. Do, I don't know, 1/21. Okay? Chances are a lot of you may even get that done in the allotted time. Okay? So if you do, that's great. Then that's one less thing you have to deal with. Right? Okay? And I think you would agree with that. If you get it done, the only problem that you may come across is if you lose the paper. And that happens. Okay. So, any questions about the rest of this week? Okay? So again, what happens if we have a review day and we don't have school the next day, we have the evaluation. If a homework assignment is given and we miss the day before, it's still due that day when you come back. And I think you would agree, if we're consistent with that, then we're all on the same page. Okay. All right. So we'll stop with this part for now. So one of the things we want to go over, okay, is doesn't look like a shark, does it? My drawing skills are not that good. Okay, which one of these? Yeah, I suppose I can get rid of this. So, it's talking about these chemical properties. Okay, so for instance, if we were to say, give me an element out of column 6, there's a whole various numbers that you could give, especially the top 2 periods. Column 6, the top 2 periods in that. Okay, so what can you tell me about oxygen as far as valence electrons? Okay, you could say 2 has something to do with it, 4 has something to do with it, and what else maybe? 6. All those 3 things have the same thing in common. This is what we mean. Okay, so inside that nucleus, we know that there's 8 protons. Okay, 1s2, 2s2, but with this, okay, there's 4, because in the P block, what column is oxygen in? In the 4th. So again, that's where that 4 comes from. But in that second period, what column is it in? It's in the 6th. So that's where the 6 comes from. So again, are we seeing where these repeating patterns are showing themselves or revealing themselves? So then you had also said -2. Well, that's true as well. Now this is a little, let's say in theater or play terms. What does it mean to foreshadow something? You're illustrating what's going to yeah, you're right, but I didn't quite hear it. Say that again. Yeah, you know what might happen. You're foreshadowing. Sometimes, how many of you are horror movie fans or fanatics? Because sometimes doesn't the music sometimes give it away that something that might be happening? That's an example of foreshadowing in the future. So, this isn't meant to confuse anybody. You might think so, but that's not what we're trying to do. Okay? This idea right here, because we're going to be talking about that tomorrow, because when we're revealing electrons, in your handout it says something about dot diagrams. We said we're going to move them to next chapter. We always do, but this is where that -2 comes from. Okay? These dot diagrams is just a depiction of these 6 electrons. These X's are electrons. And in the middle is an oxygen atom. So, if it wants to stabilize itself, it wants 8 electrons. Well, if it has 6, what happens if you have 2 more negative charges than positive charges? What do you get for a net charge? A -2. So remember, inside this atom of oxygen, there are 8 electrons. or excuse me, 8 protons. And we've illustrated, here are those 8 electrons. But what happens if you add 2 more electrons to that? Now you've got 10 total. And remember, algebra tells us when you add them 2 numbers together, what do we get? -2. And that's why that charge of -2 is inside oxygen's box. Okay. All right. If you're confused about that, don't worry. We're just foreshadowing what you'll be doing next chapter. Because some of the chemical properties of these, unfortunately, have some can be lethal side effects. It used to be, it's before your time, but when farmers would fill their silos, okay, once you get that all the way up to the top, you want to have that circulating fresh air in there for a period of time, because what happens is, whether it's, I suppose, corn silage or alfalfa, when that goes through its fermentation process, that gives off a deadly gas. And the problem is, there again, you don't notice it. And what slowly happens is the amount of oxygen, I'm guessing, inside your bloodstream starts to go down, very much like carbon monoxide. That can do the same thing. You don't notice that it's happening to your body. Okay? And again, that's one of just the chemical properties of what carbon monoxide does. It binds to... Can you give blood? Next year you can. Do any of you know what process you need to go through to donate blood? You ever heard of that? They're going to take something sharp and take it, needle, and shove it in your finger. They're doing a quick test on how much iron is in your blood. Well, why? Does anyone know why you have iron in your blood? What gas bonds to that iron, would you guess? Oxygen. So if you have a low iron level in your blood, they're going to say you can't donate to that today. Because if you have such a low iron level, you don't want to donate that to anybody, because then they're going to have a low iron level in their blood then too. So what happens is that carbon monoxide will bind to that iron instead of the oxygen. So that level just starts to go down, down, down. So a person, unfortunately, passes out, loses consciousness, and then just slowly asphyxiates himself. And again, that happens to people. They don't even realize it. That's really too bad. Another compound we're talking about that resembles this is called hydrogen sulfide. And what that is, it's a type of gas given off in manure pits. Because what happens is that, again, ferments underneath, and that gas is given off, and people don't even realize it. I've got a short segment from it was Reader's Digest, but I think it comes from, or I should say it came from Psychology Today. And I've got that. I'll certainly read. Oh, I think I found it here, because I have a hard copy of it as well. Okay. It's called, it's part of the domino effect. Again, this comes from Psychology Today. Okay. The problem began with a minor malfunction. Scott Showalter, a 34-year-old Virginia dairy farmer, was trying to transfer manure from one holding pit to another when the pipe between them became clogged. As he had done before, okay, he climbed down to free the obstruction. And sometimes we do these processes over and over and just get so used to them, you don't realize that certain dangers that could possibly be present. And I could probably see myself doing the exact same thing. Oh, this is what I did last time. It worked. This is what I did last time, and it worked. Okay? What he neither saw nor sensed was the invisible layer of methane gas that filled the bottom of the pit. I said hydrogen sulfide, didn't I? But this says methane. Deprived of oxygen, he kneeled over within seconds. When an employee, Amos Stoll, that's a German name, climbed down to Showalter's aid, he too succumbed. So what does that mean, to succumb to this gas? And unfortunately, die. Yeah, that's right. Okay, but not before his shouts drew the attention of Showalter's wife and two of their daughters, aged 9 and 11. One by one, each climbed down to rescue the others, and each one died in turn. Okay? One by one, each climbed down to the rescue of the others, and each one died in turn. Within minutes, 5 people were dead. It was the domino effect. Okay, and it just goes on to say similar tragedies play out again and again, and it's one of them aspects you probably wouldn't know. If you see a loved one down there, you're probably going to go down there and try to see what's wrong. And unfortunately, when that happens, some dire consequences can arise from that. All right. So I need to get that video rolling. So we'll continue with some of this information tomorrow and into Friday. All right. We will catch up to you next time.